Okay, great. So lightning talks now. We've got half-hour lightning talks, another talk before the end of the day. So we're in the downhill run. And I'd like to ask our first lightning talk presenter, Ondrej, Filip from CZ.NIC. And
thank you. Thank you.
Why are the slides not appearing on the big screen?
Do not speak.
There's a button.
There's a button.
No, it should be up there.
So thank you very much. My name is Ondrej Filip. I'm working at CZ.NIC, which is the top-level domain registry of the Czech Republic. For those who don't know, Czech Republic is a small country in Central Europe. It has about 10 million people and the best beer in the world. So, did I say something funny? So the main news from my presentation I would like to tell you is that we have currently almost 100,000 DNSSEC sign zones in our top-level domain, which is definitely the highest number in the world, but probably even more than all the other top-level domains in total. And the rest of the presentation would be how we get to those numbers, what we did to start up a DNSSEC in our country. So basically, before we started deploying DNSSEC, we heard a lot of complaints and reasons why not to go, like that there is no business case, that registrars really don't want it, the same for registrants, that it's too expensive, it's too complicated, and everybody pointed us to some chicken and egg problem that there is no market and things like that. And we knew that just talking about those things, we really couldn't start it up, so we took it up a little bit from a different point of view. We thought that somebody must do it if we wanted to deploy it. And we also thought about the fact that some people want to start as a special service. So we thought, well, security is probably not a special service. We believe that security is a feature. And then if we sell domains, it should be a natural part of domains. And that it's all responsibility because we are probably the only one in the game that have power to start it up. But we couldn't do it alone, so we felt the need to find some allies, like ISPs, registrars, content providers, and of course also end users. The registrars are, of course, the most important entities in that game, in the chain, so we focus our communication on them. We had several registrars and several seminars, and before and after DNS launch, we did a lot of training. We provide free training how to work with DNSSEC, how to sign domains. We also set up quite nice conditions for DNSSEC. We do not want any fee, nothing like that. Everything is free, and we made two things to make the situation sweeter for them. First of all, we have a positive discrimination in our co-marketing program. I will explain it a bit later. And also we did some technical things to help the bulk DS record registration. Basically, this is, you can see it on the screen, so how it works. If you have domain, there is usually written that somebody is registrant. There could be some administrative contacts. And in the classical EPP structure, there will be a technical contact and a list of name servers. We a little bit changed that scheme, so the domain doesn't include list of name servers, but it points to a structure called NSSet, and this structure includes name servers and technical contacts. What that's good for? It's good for bulk registration. If you have 1,000 domains and all of them have the same name servers, you don't have to create 1,000 objects in our database, but you just create one and you point all domains to the object. And if you want to change those name servers, you just do one single operation. And we reuse that philosophy also to another object called keyset. it's not a DS record, it's a key set, and this key set can also include several DNS keys and several technical contacts. So if we generate the zone file, we compute those DS records instead of the domain name technical contact. And again, you can have a million of domains, and you can have just single key that signs all of them. And if you want to do a key rollover, you just change one single item in our database, and you can basically do it. And you can do all the other work on your side. So that was how we helped them technically to do the bulk DS record registration. In the co-marketing, we usually do that if a registrar wants to market domains, if he's so brave enough to do so, that we pay 1/2 of the campaign, and the maximum limit of the campaign is based on registrar performance. So to help them to promote DNSSEC, we allow to increase that limit if they have some certain number of DNSSEC registrations, some bonus for DNSSEC signed zones. And surprisingly, even during 2009, some registrars started campaigns that were focused on DNSSEC, that were explaining that DNSSEC is important and that people should want it. We also try to communicate with end users. We had a lot of conferences and some sort of marketing communication with the end users. We put a lot of articles into the newspapers. One thing that really was very successful, it was last year when Czech Republic held the presidency of European Union, and the official domain of the presidency was EU2009.cz. We signed that in the middle of the presidency, and it got a lot of media attention, so people knew that something can be improved in the domain name security. And for more empowered users, we did some nice tools in our research part of the company. We call it the CZ.NIC Labs. That was DNSSEC hardware tester. You can also try it here if you want. It's basically a tool that tests your DNS resolvers. That should be probably on your, for example, ADSL modem or your CPE device, your home, and it tells you whether this device is DNSSEC compliant, whether this resolves and works fully with DNSSEC, and surprisingly many of them do not. This tool is open source. It's for Windows, Linux, and Macintosh, and you can download it from www.dnssechtester.cz. It is in English, Czech, and also Hungarian, because the Hungarian registry joined that activity. So, but if you want some other language, just let us know, send us the translation. We'll be more than happy to extend this project. But you North Americans probably just can leave it in English, I guess. Another tool that people likes is a DNSSEC validator. It's a Firefox add-on. We had the problem that we couldn't visualize DNSSEC for normal people. If they sign the domains, nothing happens. It's not visible because those people do not understand DIC. So they wanted to see somehow that they have signed domains and everything is okay. So we did this Firefox add-on, which looks similar like a HTTPS in Firefox. If you install this plugin, and some DNS domain is signed, it will show a key, and the color of the key shows you whether you have a validating resolver, whether the domain is properly signed. If it's not, it can show the reason what's happened. It can use the resolvers in your computer, or you get from DHCP, or it can show some open validating resolvers that provide CZ.NIC or ORAC, for example. So it's a very nice tool, and it's really handy for people that want to see DNSSEC, and it's very hard to do so. It's on dnssecvalidator.cz, or just type DNSSEC at Mozilla add-ons and you can download it there. It's still in beta stage, but we are close to make a final version of that. But it has a lot of downloads. It's a really popular toy. So I didn't describe everything, but we put a lot of energy into promoting DNSSEC, and we start in September 2008, and you can see the numbers of DNSSEC signed domains just slightly growth. At the end of the 2009, we have about 1,500 sign zone. That's really nothing really impressive. But next year, the situation changed dramatically. As you can see, there are two big steps that really changed the numbers dramatically. So what happened? Two big registrars just enabled DNSSEC by default. For all domains they are hosting on their DNS servers. They do not charge any additional fee, although before they tried to, but now they just put it free. And they felt that they could get some marketing advantage. Surprisingly, this was very well communicated in the media, mainly because many of the magazines had domains on the name servers of those registrars. So they knew that something happened, and they knew it's probably good, so they wrote some articles that some security were improved on their magazines and so on. And really the market share of those registrars, it's very good, and we are definitely not losing, so it helped a lot. And we are actually at the end, so I wanted to show you an example that DNS can be deployed at large scale. It's really not so complicated, although the registry has to start it up. We are pioneering this thing, so we found some bugs and small problems in current DNSSEC implementation, but we are fixing that, so you will probably not see it if you will do it. There are, for example, some bug in DNS resolvers that were found by a company which is a Czech Google mainly. It's a web search engine used in Czech Republic. It has a bigger market share than Google in our country. It's a specialty, and they use this for validating resolvers for DNSSEC, and we found that there are some bugs in implementation and so on. But anyway, those things are fixed, and we are on the right track. So Czech Republic is the most secure DNSSEC country is the most secure DNS in the world and the last things, we have some more news to come. We are now using NSEC because we started very early in 2008. So now we are switching to NSEC 3. We did it for our enum zone, and in the middle of, in the beginning of August, we plan to do it also for the .CZ domain after the root zone will be signed out. So just a last slide, because you survived those all talks about Europeans. I would like to show you how things started. There were also two North Americans involved. As a typical Czech tradition, we take an important decision in a pub. So we went to a pub, drank a few beers, and then we became very decisive. And we promised Steve Crocker that we will really move up with the DNSSEC. So you can see there's Steve Crocker, me, Ondrej on the right-hand side. He's currently close to Washington D.C. on key ceremony actually. Thomas Marsalek and also a guy that is currently on that ceremony as well. So thank you very much. That's all.
Thank you very much, Thomas. Sorry, Ondrej, miles away. It's been a long week. So thanks very much, Ondrej. Unfortunately, we can't accept questions because lightning talks are only supposed to last 10 minutes, including Q&A, and that went over 10 minutes. I'd like to invite our next speaker, that's Michael Sinatra, to take the podium.
Okay, thanks. I want to talk a little bit about DNS curve versus DNSSEC. I think a lot of us know what DNSSEC is. Obviously, we just had a talk about it. Not everyone knows what DNS curve is, and not everyone knows that there's kind of an argument that's raging on anywhere between 1 to 2 mailing lists. Occasionally flares up about DNS curve versus DNSSEC. There's an interesting point of view that sometimes comes up which says that we, instead of deploying DNSSEC, we should deploy DNS curve. So not everyone may know about this. Some people may, to those of us who have our heads pretty deep in this, may understand the differences pretty well, but not everyone in your organization may understand that, and you may have to explain it to them sometime. So I do want to say that I don't participate in the standards process. Nick Weaver, who works elsewhere in Berkeley, at UC Berkeley, does do that. And so if you have problems with the way the standards processes are going, please give him a good talking to and not me. And the other thing is, these are my own opinions, and my colleagues who are in the audience will tell you that sometimes they don't even think I believe the things that come out of my mouth, and that's probably true, so we'll just see what happens. I like to make analogies, and I like to argue. So argument by analogy is kind of a nice thing for me. When you talk about argument by analogy, there is actually a whole sort of school of thought on this, and the way you do it is to really try to be a little bit more systematic in the analogies you choose, and also in the way that you present the analogy. So you don't simply say things like DNS is a stage and all the queries are players or something like that. You try to be a little more careful than that. So I'm going to present an analogy, and kind of give try to use the analogy to kind of bring out some of the different key features and some of the conclusions that we come to. And I might mention the word isomorphism, I might not. It just simply means that it's the components of the analogy that map to the thing in the real world. And in the example that I gave of analogy, where you take a free market is similar to international politics, in that same example, then a firm would be a country. Countries would be like firms interacting in the market. So I think just for reference, we're going to talk a little bit about how DNSSEC is defined. I think we all know what DNSSEC is. DNSSEC provides digital signatures. Using that kind of cryptography, it allows people to validate the DNS responses that they're receiving at their resolvers. DNS Curve actually provides something different. It provides link layer security, or transport layer security, if you will, of DNS responses, and it actually encrypts them in ways that make them difficult to be eavesdropped upon. So here's the analogy. In a DNSSEC world, the analogy goes something like this. I'm going to write a memo and send it to my colleague Mark at UC Santa Cruz. So I write the memo. I use a kind of indelible ink so it can't be erased or altered in any way, and then I sign it. I sign it with a signature that's very, very, very difficult to forge. So just imagine me signing it with a pen, with maybe one of those big magic markers that really smells like ether. It's kind of nice to inhale. So I do that, and then I just hand the memo to my secretary. Now, of course, this is a very contrived analogy because I don't have a secretary, and I don't think Mark does either. But my secretary then takes the memo and hands it to a courier, who then maybe hands it to another courier, and then it goes to Mark's secretary, and Mark's secretary hands it to him. He can then look at the memo. He can see my signature. He knows that it hasn't been altered in any way. The memo has not been added to. It hasn't been subtracted from. It hasn't been changed in any way. So that's how the DNSSEC memo works. The DNS Curve memo is a little bit different. I write the memo, but I don't actually bother to sign it. Instead, what I do is I fold it up and I take it and put it in one of those security envelopes with a little design on it that you can't see through. And then I sign across the seal of the envelope. So everyone knows that the envelope, or at least the person who receives the envelope, knows that the envelope was mine and I put it in the envelope. Then I hand it to my secretary, who opens the envelope, discards it, takes the memo, puts it in a new envelope that he then signs across the seal, and then hands it to the courier, who opens the envelope, discards it, takes the unsigned memo and puts it into a envelope that she then signs across the seal. Then hands it to Mark's secretary, who opens the envelope, discards it, and then signs across the seal again, and so on. And then that gets handed to Mark, who then looks at the signature and says, oh yes, my secretary did in fact send this to me, and opens up the envelope and looks at the memo and reads it and does whatever needs to be done. So the difference is in the case of DNSSEC, the memo is signed and you can actually validate that the memo is actually authentic. In the case of DNS Curve, you can't validate that the memo is authentic, but at least you know that you can validate that it came from your secretary and that nobody saw it in between as the secretary was bringing it in. Nobody was able to see what the memo had on it. Whereas in the DNSSEC memo, the memo is just being handed to people. Anyone can look at it. Or anyone who's close by can look at it. Okay, so if you think about this particular analogy for about 2 seconds, one of the interesting isomorphisms that comes out, one of the first things you're going to ask is, why can't I just sign the memo like I did in DNSSEC and put it in the security envelope? And there is no reason you can't do that. And in fact, in DNSSEC and DNSCurve, there really is no reason that you can't implement both. So when people start arguing about this and start saying things like, you can't do them both, or you shouldn't do them both, you should do DNSCurve instead of DNSSEC, it turns out that it's kind of like saying you should run Windows 7 instead of using high-octane gasoline. That's also an analogy, and that's a little bit contrived, obviously. But for some people, you know, they obviously they solve different things. There are some people who may want to use high-octane gasoline. There are some people who may want to run Windows 7. They solve different things. It's sort of the right tools for the task. For me personally, I don't have much interest in my DNS data being non-eavesdropped upon because I see DNS as the phone book. And so it's sort of like saying you need to encrypt the phone book. It's really not all that important to me. So I think that what we are looking at actually as the first slide, as the title slide implies with the apple and the orange, this is a false dichotomy. This is really an argument that doesn't need to happen anymore. What we should basically just do is finish standardizing what needs to be standardized, let the implementers implement what they want, and let the ops guys deploy what they want and move on. I have the analogy sort of written up at that URL, and that's it. So if there are any questions.
We do have time for questions.
Great. So then everyone else thinks the argument's stupid and they all agree with me. Thank you.
If there are no questions, thanks, Michael. And our final lightning talk for this right meeting. Now, I'm having a really bad week, aren't I? Is the inimitable Todd Underwood. Yeah, it's Windows 7, I think, as well. It is.
Lightning talks, okay. Now it's PowerPoint. It's like F5 or some shit. Okay. Okay, so I'm Todd Underwood, and I am not representing any company for the purposes of the suggestion that I'm about to make. So please do not discuss this with any past or prospective employers or current employers. Thank you very much. So this talk is entitled Prefixes as Probabilities, and it is a modest proposal to radically extend the useful life of IPv4. So here's the problem as we know it, and I'm going to talk fast because I would imagine there will be a certain amount of throwing of fruit or kvetching at the end, or just conventioning, which is like when you kvetch by just mentioning something, you're going to like it. Okay, so here's the problem as we know it. Everybody knows v4 prefix space is running out. IPv6, in spite of what Martin Levy will tell you, is not operationally equivalent to v4 yet. Now, a lot of people are doing a lot of hard work, and I've bashed v6 many, many times publicly in the past, and it's getting there, but no one sane thinks that this transition is going smoothly well or that it's all going to be ready by the time things start getting bad. Time is running out, and if there are any mechanisms to usefully extend the life of v4, we should do those. People have looked at a bunch of these, right? So address market and trading, the sort of anti-capitalist, anti-libertarians have had a field day with that, but the reality is Jeff Houston presented some great numbers on the way in which that can extend things by slowly raising the cost of the remaining v4 space and underutilized v4 space to pay for transition and justify transition to v6. So we're looking at that. There's rationing or just flat out running out and being done. Okay. So how does resource allocation work now? This is a 50,000 meter perspective from somebody who's not very bright and doesn't understand the policy process very well. So RIRs allocate resources on a 0-1 scale. It's entirely stochastically divided. You either do or do not get an address, and someone else either does or does not get it. In the normal case, an address is allocated to your organization. I'll speak about addresses, but mostly because I think that 32-bit ASNs nicely solve the problems for that's the main other number resource. So mostly we're talking about prefixes, although I think this idea extends to any other finite resource that might be running out. But mostly we're talking about prefixes here. So the odds that someone else has been allocated the resource that you've been handed are very, very low. Now, there were some interesting cases recently where organizations ended up with the same ASN. And early on in my career, I may have done some network support for a large-scale power utility, and they had a /24, a legacy /24 allocated. And they started running out of space, so they just kept going. They just kept going. And they changed it to a /23 on their routers, and they just kept going. And then they ran out of that, and so they changed it to a /22. And about 7 years later, they called us up because we were their service provider, and they said, we can't get to this power broker something in Tennessee. I was living in New Mexico. So that's really interesting because I can get to them just fine. And it took a little while because the idea that maybe they had just used more addresses that were close to the addresses that were theirs had never occurred to any of us. It just seemed like such an appalling, bizarre idea. And yet that's what they had done, and they'd been doing it for 7 years. And to be honest, I don't know whether they're still doing it, because here's how they solved this problem. The main problem was they couldn't mail these guys, and they were thinking about buying some consulting services from them. And so what they did is they unallocated the /32 that was that company's mail server and set up a static pointing to us for that and kept going. There's a lot of ways to solve these problems, ladies and gentlemen. So, the disadvantage of this strategy that we have now, it's extremely discrete, yes or no. It requires all manner of external factors in order to tune the allocation depletion rate. So people at Aaron, people at Wright talk a lot about how can we slow down the rate of this? How can we raise the cost or raise the hassle of this stuff going so that we have a more graceful degradation? Okay. And the market or transfer policy does some of that, but to be honest, I mean, this is not to diss any of the organizations like Ripe and Aaron that have implemented this, but it has a very, very high transactional friction. This is not like go to eBay and buy something, which is what people really wanted. So here's the thought experiment. Allocate truly unique, and I know unique just means unique, but for emphasis, sometimes I'm going to say very unique or truly unique just to piss off the grammarians in the crowd. So, allocate extremely quite unique addresses to people who really need them and charge an insane premium for them. And massively discount addresses that people are willing to consider being multiply allocated according to a probabilistic function. In other words, explore the probability space that is completely empty between 0 and 1 in the address allocation scheme. So this is a continuous space. Now, we can think of simple ways to look at it in terms of, oh, some people might hang out in the 20% or 50% or 0%. But in reality, this is a continuous space, and it lends itself to all kinds of market mechanisms. So what are the advantages? This will massively extend the lifetime of V4 space by permitting multiplicative reuse of the remaining resources. To the extent to which we can allocate the same prefix 10 times or 100 times or 1,000 times, we're going to be able to get some amazing lifetime out of that. And I've got some modeling that I'm going to show, but it's a lightning talk, so it's very early work, and a lot more thinking needs to be done on this. It creates the possibilities of a fantastic derivatives market. It makes it really useful, right, it makes it useful to, so there's dirty space, right? Vince did a great presentation on, well, we want to reuse this space, but it can't be reused because some routers can't reuse it, or some people won't be able to carry it. Well, don't let those people carry it. Let someone else carry it who is willing to carry that. 1/8. You guys saw presentations on that. It's dirty, it's imperfect, nobody likes it, blah, blah, blah. Well, what if somebody's willing to take it? What if, like, 2,000 organizations are willing to take it? Okay? Space expansion could be substantial. So modeling the space advantage, I'm not going to present real equations here because it's a lightning talk and this is early work. But if you consider C... I knew I'd get laughed at, and if you consider CR to be the count to reuse, we're going to talk not just about a collision, but the operational overhead of a prefix. How much work do you need to do to make a prefix usable? Because that's an entire space of work. It could be a single collision that prevents your customers from using it, or it could be a variety of other functions about how much work you need to do to route it and reroute it. And the association domain for a prefix, this is the likelihood, this is a way of representing the likelihood that that prefix will be in operationally conflict with some other use of that prefix. So the probability of the operational overhead of a prefix being positive is obviously some sort of function of the count of reuse and the association domain for the prefix. So future work is to work in particular on the association domains because I think that's where the bang is here. So look, collision avoidance and detection, there's some really good early promising work on this and a lot more thinking needs to be done. We can use time-limited addresses, right? Not everybody's awake all of the time. Pull them up, take them down. Like there's 24 hours in the day and even you guys sleep sometimes. So we can have geographically limited address domains. So what if you only want it to work in Europe? Why does somebody else have to burn a whole address just because you're using it in Europe? It doesn't make any sense. So there's the market address for the domain. This is association. This is with the association domain for a prefix. And finally, you can implement the provider isolation selection system. So you may choose to pick particular addresses that are in use. Like let's say, not to pick on anyone, but what if Cogent has an address and you want to ensure that this customer can never reach Cogent or anything Cogent carries? Well, then you guys might mutually agree to just segment that particular customer space. So each of these is going to need to be modeled. So there's some engineering challenges. Prefixes are going to be multiply originated. They're multiply originated now. We can explore this space. Many conflicting uses will be minimally disruptive. This could be used by providers to limit peer-to-peer access. Like if Comcast, Verizon just both use all the same space. Why don't they just both use all the same space so their customers can never talk to each other? Okay? It's an idea. Market mechanisms need to be developed. Now, the actual detection of collision mitigation and the modeling of these prices is going to need to be done by groups by the RIRs. In order to do that, I would suggest flow instrumenting the Internet Core at a high rate so that we can determine, like the question is, when have we gone too far for this particular resource? So this is all, look, this is a little bit nutty. It's all very, very difficult work, but the payoff is insane. This can make us safe from V6 again. So that's it. Any questions? I'll defer to the moderator for selection of the order of questions, and Michael has one as well.
There's time for questions, but I am actually going to close the line after Martin Levy.
Okay.
I'm going to let.
Nope.
Go, Dave.
Dave Temkin, Netflix. So all this talk of derivatives, it sounds a lot like oil trading. So with this, would you possibly be the BP of IP addresses at this point?
Yeah, no, it's not clear to me, but I think you can fund a lot of good registry work, and there's going to need to be a lot if we're going to instrument the core of the Internet on offsets on the trades. Absolutely. Absolutely. Let's go to Mark Costers in the back.
So, Mark Costers, Aaron, this is truly fascinating and mind-numbing work. So I really see this as fraught with peril. And what I really like to see happen is that the Aaron DC take up all the policy implications of this and put together some good proposals as we go forward.
And I'll be happy to work with people on the Aaron Advisory Committee and other people on Aaron's board to really figure out how we can implement this. We need a policy framework around this, obviously. Martin.
We've done a lot of work to really push V6 at Hurricane Electric, and I did notice that you said right at the beginning that this is independent of your current employer. If you need to send a resume somewhere after this, please, I want to hear.
Believe me, Martin, you don't know how much I am grateful for that offer. If there are any Google employees in the crowd, please don't say anything about this. Thank you. I guess Leo in the back. Yeah.
Leo Bicknell, ISC. So apparently in your presentation you have concluded that I am insane because I do feel that the entire V6 thing is more or less like Y2K. There's an awful lot of people panicking and an awful lot of nothing is going to happen. I actually think it's going okay. So since I'm insane, I'm going to pretend that you're serious for a moment.
Thank you. This crowd is a tough crowd, and it's really hard for me to be taken seriously by anyone, let alone.
It is. So I just wanted to point out two very, very small things. First of all, you're really in the wrong forum here. You really should be giving this presentation at Aaron and Bripe and AP.NIC, and I think they would be much more interested in the idea that you have. So I encourage you to go to those forums.
Sound point. Thank you.
And secondly, I would like to point out that there are already many ISPs in this room that offer both probabilistic prefix and packet delivery. So you can, in fact, purchase this service already if you select the right provider.
That's an excellent point, Leo. Thank you. I view that as an existence proof that this is a good idea. Let's go to Joe over in the corner.
Underwood from Renegoog. I think this is great. If it's good enough for the electrons and small particles that are making up that podium, it's good enough for our packets.
Thank you. Thank you. Come on, speed it up, guys. Let's go.
I just had a quick query. What kind of pharmaceuticals led to this?
I think it is lost in the sands of time where great inspiration comes from. And this is just one of many fantastic ideas I have day in, day out. Anton Capella.
Anton Capella, 9.5's data. Who got that? And Todd, I love your presentation. You're the most compelling,
Thank you.
village something in the entire crowd. But there's a simpler solution here, and Bellevin did it already. RFC 3514 gives us a flag. We can use that to take the remainder of the header and have 64 bits of host address, and 1 bit to designate 2 are from Google. It's so much easier. 3514, the evil bit.
Do you? Wow. So Tony, what I'd like to do is get people who are interested in this idea, and that's that might be dramatically simple. I'm not wedded to that. This is just one proposal, and so
no, I like simple for my CRAP
if that's a good exactly. No, that sounds like really good work, and I'd like your help in pursuing these ideas.
Thank you, buddy.
Thanks, Brandon.
Brandon Ross, Subspace Communications, Story Point, whatever. I've kind of observed that you're trying to do this to avoid V6, but have you thought about applying these concepts to V6 as well?
I am intrigued by your theory.
I'd like to point out that if you say, apply the same V6 addresses to certain entities and share the same with certain other entities on the opposite side of the world, then maybe that whole lack of NAT in V6 thing is solved.
Brandon, I am intrigued by your theories. Do you have a newsletter to which I can subscribe? Yes. Last question in the back, I think, and then we're done.
Lee Howard.
Oh, sorry. Go ahead.
Lee Howard, and I choose not to affiliate. So I'll start with I actually have had a very similar idea. I chose to keep it to myself.
If you have lessons on how to do that, I would be happy to have them.
There are lots of interesting ways that we can create pockets of unreachability on IPv4. This is but one of them. There are, in fact, people doing essentially this now by using what we call squatted address space internally. And so this is, looked at from that perspective, this isn't quite as crazy as it seems.
So you're saying there's lots of good ideas here. That's what I'm hearing you say.
Expressed in a completely different way, there is something here that's sane. So I guess I also want to try and treat you a little bit, treat your suggestion a little bit seriously, and say there is potential room for work here. I'm not quite with Mark on directing the advisory council and actually it's my job to direct the advisory council to provide advice. I'm not going to ask the advisory council to do that just yet, but they have brains of their own and can come up with their own ideas too.
Excellent.
Thank you.
Thanks. Michael, very quickly.
Yeah, I have a question. Michael Sinatra, UC Berkeley. Actually, it's a comment. This proposal provides all of the benefits of things like carrier grade NAT, but none of the complexity. It reduces a huge layer of complexity. And since we all know that the more complexity you have, the lower the reliability, this has the potential to be significantly more reliable than carrier-grade NAT. So
I'd like to talk to Comcast about this later on. So thank you all for your time and attention. If you're interested, help me.